Bismillah ar-Rahman ar-Rahim. Now we'll try to do this hyperbolic functions. Actually, there's not much to say in this section. This is just a review. What was the definition of the sine hyperbolic, cosine hyperbolic, tan hyperbolic, which we did in Math 101. And then these are some of the identities which may will help to do the calculation. Now this is what we want. This is the new thing. I know that the derivative of sine hyperbolic is cosine hyperbolic. That means the integral of cosine hyperbolic is sine hyperbolic plus c. Cosine hyperbolic, the integral of sine hyperbolic give me cosine hyperbolic plus c. Secant hyperbolic square is tan hyperbolic. Cosecant square is minus cotangent hyperbolic. Secant tan give me minus secant hyperbolic. Cosecant cotangent minus cosecant hyperbolic. So I need these formulas just with sometimes with some substitution. So that's exactly what we need in this section. Okay, so if I need to do the integral of this, cosine 2x, cosine hyperbolic 2x, sine hyperbolic square 2x, very clear. I will take this u. I will let u equal sine hyperbolic 2x. My du will be 2 cosine hyperbolic 2x dx. So I need 2 and half outside. So the integral will be half. Let me call it I to save time. I will be what? Half integral u square du. So that will give me half u cubed over 3 plus c. What is u? Is sine hyperbolic. That will be 1 over 6 sine hyperbolic cube 2x plus c. But just I'm doing substitution, nothing else. Sine hyperbolic 1 plus sine hyperbolic square dx. Very clear. I will let u to be sine hyperbolic x. Okay. Du will be what? Yeah. Will that do it? No. Okay. That means I need to do what? I need to rewrite sine hyperbolic square to cosine hyperbolic. Okay. And see what will happen. I know in cosine hyperbolic square minus sine hyperbolic is equal to this one is what? I know in cosine hyperbolic square, the identities minus sine hyperbolic square, that's equal to 1. So that means cosine hyperbolic square is 1 plus sine hyperbolic square. So this integral, call it I, don't do it, will be integral of sine hyperbolic x over, that is I, over cosine hyperbolic x dx. And in other words, that will be what? That will be tan hyperbolic. Let me just do it in more steps. That will be sine hyperbolic x over cosine hyperbolic x times 1 over cosine hyperbolic x dx, which is what? Which is tan hyperbolic secant hyperbolic x dx, which is, if you look at the formulas, which is this one. So the answer is minus sine hyperbolic plus c. Okay, so sometimes you need to manipulate it a little bit, then we can do the integration. Tan hyperbolic. This one, I can make it 0 till into sine hyperbolic over cosine hyperbolic dx. Now I will let u cosine hyperbolic du will be sine hyperbolic dx. So that will be what? Be careful now with the calculation. Now, I'm letting you cosine hyperbolic. So cosine hyperbolic 0, that is 1. I know that cosine hyperbolic 0 is e to the power 0 plus e to the power minus 0 over 2. That will be 1. Now, what about cosine hyperbolic ln 2? That will be e ln 2 minus e minus ln 2 over 2. That will be 2 minus half over 2. That will be what? 3 over 4. So that will be 3 over 4. Okay. And that will be du over u. So it will be ln of u. That will be, no, sorry. This is plus. This is cosine. So this is plus. So that will be 5 over 4. Not, this is plus, not minus. Huh? Cosine is plus cosine. This is cosine, not sine. Okay. So this is 5 over 4. That will be ln of u from 1 to 5 over 4, which is giving me ln 5 over 4 minus ln 0, which is 1. So this is really my answer. Okay. Cosine hyperbolic square dx. What shall I do? You go back to the properties, not this one. I don't have any formula there. But look here, I have this. So this is what I will do. This one, cosine hyperbolic square is half plus half cosine hyperbolic 2x dx. Now I can use that, and now I can do the derivative. That means this one will be what? Half theta. Okay. Will be half theta. Cosine hyperbolic square is half plus half. It's half plus half. So that gives me x, not theta, sorry. I'm using x. So that will be half x plus 1 over 4 sine hyperbolic 2x from 0 to 1. You can check it. This is derivative half. This is derivative 2 times 1 over 4 half cosine hyperbolic. Okay. You can do it by substitution, or you can do it right away like this. Now substitute, you have half plus 1 over 4 sine hyperbolic 2. Okay. Minus 0. Sine hyperbolic 0 is 0. So minus 0. خلاص. No need. Or you can rewrite it as half plus 1 over 4. This is 2 sine hyperbolic 1 cosine hyperbolic 1. And that will be half plus 1 over 2 sine hyperbolic 1 cosine hyperbolic 1. Okay, let me do, this also. Now he makes e minus x with cosine hyperbolic. What I will do, I will rewrite cosine hyperbolic as an exponential, which is e to the power x plus e to the power minus x over 2 dx. Then I do the calculation. That will be 0 ln 2, 1 plus e minus 2x dx. Now integrate, I have x minus half e minus 2x. This is from 0 to ln 2. That gives me what? Ln 2 minus half a minus 2 ln 2 minus 0 minus half. E to the power 0 is 1. So that gives me ln 2. This one is what? This will go as a power. So I have 2 is minus. That will be minus 1 over 8. Huh? This will be that will be 1 over 4 times half. That will be minus over 8 plus half. So that gives me 4 over 8 minus 3 over 8. 3 over 8 plus ln 2, which is the answer. Okay. This is from the old exams. This is the only one I saw in the old exams. There are other ones. I think this also was in the old exams. I forget about it. Okay. This one, I can rewrite this as well as 4 ax minus minus x over 2 dx. So that gives me what? 2 e to x minus 1 dx. Let me take the 2 outside. I have what here? Half e to x minus x. This is from 0 to 1. So that gives me 2 half e squared minus 1 minus half minus 0. That gives me what? 2 half e squared minus 3 over 2. In other words, a squared minus 3, which is this. Okay. Now we'll try to do all of these problems from the book. Yeah, let me do it quickly. Let's do it quickly. 45. Integral of cosine hyperbolic 4x dx. Yeah, this is what? This is 1 over 4 sine hyperbolic 4x plus. Yeah, can do it quickly or can do it by substitution. I take this u. Yeah, now substitute, now differentiate. I have cosine hyperbolic 4x times 4 times 1 over 4, which is the answer. Yeah. So this is quick one. Nothing in this section, just you need to do substitution. 46 integral, yeah, integral of secant hyperbolic square 3x dx, which for sure I will use this problem. I'll use this this one. So just I will make it u. You can do it in steps, or you can do it quickly. I can let u equal 3x. So du will be 3 dx. So I need 3 and 1 over 3 outside. That gives me 1 over 3 secant square u du. That will be 1 over 3 tan hyperbolic u, which is 3x plus c, or you can do it in one step, like this. 47, same idea. Sine hyperbolic 1 minus 2x dx. So now I let u 1 minus 2x, du is minus 2 dx. So I need minus 2 and minus half outside. That will be minus half sine hyperbolic u du. So that gives me minus half cosine hyperbolic of u, which is 1 minus 2x plus c. 48. Let u equals square root of x. Du will be 1 over 2 square root of x. So I need 2 and 2 outside. So that gives me what? 2 cosine hyperbolic u du. And the answer will be 2 sine hyperbolic u to square root of x plus c. This one, 49. I let this one I did. No need to do it again, huh? 50. We did here. Okay, no need to do it again. Yeah. Let u equal cosine hyperbolic x minus 1. Du will be sine hyperbolic x minus 1 dx. So this is will be du. So this I, so I will be integral of u squared du. And that give me u cubed over 3 plus c. I think we did before. Yeah, somehow similar to this one. Yeah, actually this one is easier. So that give me 1 over 3 cosine hyperbolic cubed x minus 1 plus c. 50 I did. 51 integral of cosine hyperbolic x over sine hyperbolic x dx. Yeah, I let u equal sine hyperbolic. I let u sine hyperbolic. Yeah, the denominator. Du will be cosine hyperbolic u du dx. What is this? X dx. That means this one is du over u. That would be ln of u plus c. That would be ln sine hyperbolic x plus c. Okay. 52. I let u 1 over x du is minus 1 over x squared dx. So I need a minus here and the minus outside. So this one will be minus cosecant u cotan hyperbolic u du. This is will be my du. Okay. What is cosecant hyperbolic cotan hyperbolic? You look at the formulas. This one, it's minus cosecant hyperbolic. So that give me what? Yeah, give me minus times minus cosecant hyperbolic u, which is 1 over x. This is what 52, which is 1 over x. Yeah, which is 1 over minus. No, it's minus cosine hyperbolic 1 over x plus c. So it will be cosine hyperbolic. Cosine hyperbolic 1 over x plus c. Okay, more problems. Let u x squared over 2. What will be du? It will be x dx. So 53. Yeah, let me write this one. That will be integral cosecant hyperbolic square u du. Okay, what is cosecant hyperbolic square? If you go back to the formulas, secant hyperbolic square is minus cotan hyperbolic. So that gives me minus cotan hyperbolic u, which is x squared over 2 plus. Okay, 54. I let u to be tan hyperbolic or secant hyperbolic. This one interesting. No, first I need to rewrite the function. Yeah, that will be I call it R, or let me write the integral. Yeah, I need to do a trick here. This one, it will be secant hyperbolic square secant tan hyperbolic x dx, where the trick is what? I'll try to rewrite this. This is my du with the minus sign. Huh? So I need the minus sign here. the minus sign outside. So I let u secant hyperbolic x du, I need a minus sign. Okay, dx. So this integral, call it I will be what? Minus u squared du. So it's minus u cubed over 3 plus c, which is minus 1 over 3 secant hyperbolic cubed x plus c. Okay. This one. Now, as I said, I'll try to do all the problems in this section. 55. I think 55 we did, huh? 55, 56 we did. So I don't need to do it again. Yeah, 55 done, 56 done, 60. Okay. So let me go back to 57. Integral from 3 to 4 is secant hyperbolic x minus 2 dx. What I will do, I will let u x minus 2 du equal dx. Now do the integration. That will be what? 3 minus 2, that will be 1. And 1 to 2 will be 1 to 2. Okay. Cosecant hyperbolic square u du, which is, I know, this is what? Formulas. Cosecant minus cotan hyperbolic u. That will be minus cotan hyperbolic u from 1 to 2. So it's minus cotan hyperbolic 2 minus cotan hyperbolic 1. You can leave it like this. 58, same idea. Now I let u to x minus 1. So du is 2 dx. So I need 2.5 outside. So that would be half integral of what? Half, it will be 1 minus 1, that is 0. Integral of 0. And at 1, it will be what? 1. So I have what? I have secant hyperbolic square u, and this is going to be du, which I know this is will be what? Secant hyperbolic square. You go back to the formulas. It will be tan hyperbolic. Right away, I'm getting half tan hyperbolic u from 0 to 1. That will be half tan hyperbolic 1 minus tan hyperbolic 0, which is 0. This one 0. So I see half tan hyperbolic 1. Yeah. Okay. 59. Very clear. I let u 3x minus 4. Du will be 3 dx. So I need 3 and 1 over 3 outside. So call it I. So I, this is 59. I would be what? 1 over 3 integral of what? 5 over 3, that give me 1. Okay. And yeah, 5 over 3, that will be 5 minus 4. 2, that give me 2. So is it what? 6 minus 4, which is 2. Okay. And cosecant u cotan hyperbolic u du. I know this is minus 1 over 3 cosecant hyperbolic u from 1 to 2. That give me minus 1 over 3 cosecant hyperbolic 2 minus 1 over 3 cosecant hyperbolic 2. You can leave it like this one. There are 2 more problems in the question, in this question, find the area. The others are related to secant hyperbolic inverse, that's the tan hyperbolic inverse, which is not part of this course. So this one I need to find the area. So the area, and this one, we say 89, it will do 89. Very clear, the area will be the integral from -4 to 4 secant hyperbolic x over 2 dx. We can make it double, yeah, because it's an even function. Or we can do it by the calculation. So what I have this one secant hyperbolic x over 2. So I don't know how to do this. There is no formula for this one. However, this one I can rewrite it as -4 to 4. This is 2 e to the power x plus e minus 2 to e to the power x over 2 e to the x over 2 plus e minus x over 2 dx. Okay, now how to do such integral? I can multiply by ax over 2 over ax over 2. That will not make a difference. So that will give me what? Integral -4 to 4 2ax over 2 over ax plus 1. Or I can say, I can leave it like this. Ax over 2 square plus 1. I think this will make it better. You know what? Let me make it in a better shape from the beginning here. I let u equal x over 2. du will be half dx. So I need half and 2 outside. So that will be 2 integral of what? -4, that will be -2 to 2. This one will be secant hyperbolic u du. Yeah, that will make it easier. Then I have 2 integral -2 to 2, 2 over e to the power x, e to the power u plus e minus u, which is the reciprocal of cosine hyperbolic. That now multiply now by e to the power u over e to the power u. That gives me 2 -2 to 2, 2eu e to u plus 1. Don't forget this is du. Huh? No. This is du, not dx. Last time I'm dealing with u, du. Now I let v e to the power u. So dv e to the power u du. So this integral will be what? E minus 2 will be e minus 2. Here I have e square. I have there what? This would be 4. V, dv, this would be dv over v square plus 1. And that will be 4 tan inverse of v from e minus 2 to e squared. And that gives me what? Yeah. Is it? Where is minus 2? Is it? I took 2. Wait a minute. U equal x over 2. I don't know if I'm mixing it. That will be minus 2 to 2. Okay, minus 4. Which is minus 4 to 4. Okay. Minus 2 to 2 secant hyperbolic. That will be 2 over this. That's e to the power u over e to the power u. That'll give me e to the power 2u plus 1. So let v equal e to the power u, that will be dv over v squared plus 1. That will be 4 tan inverse v, which will give me what? Yeah, it gave me 4. Why? I have to. Yeah, 4 tan inverse of e squared minus 4 tan inverse e minus 2. Yeah, I think that this will do it. Okay. Okay. Let me do. Yeah, this is an answer. I did not do any mistake. Huh? This one u. So du will be half. I need half. I need 2 outside. So now this is secant u du from -2 to 2. -4 and 4. Okay. 2 outside. Took it outside. That will be 2 of this. So it's 4 multiplied by e to the power u. So this is du over u over dv over v squared plus 1. I change the limit also. E is -2 to e squared. So yeah, it will be 4 times number c. Maybe the book wrote it in a different way. No problem. 90. I need to find the area, which is from 0 to 2 tan hyperbolic x to x dx. That will be from 0 to 2. I'll write the formula. That is e to x minus e is minus 2x over ex plus e to x, e to x plus e is minus 2x dx. That will be tan hyperbolic 2x. Yeah, the idea is very clear. I let u e to x plus e is minus 2x. So it will be du. It will be, let me write it here. So du will be half e to x minus half e minus 2x, which is half this one. Don't forget the dx times dx. So I need half and 2 outside, where this is my du. So it will be the answer. I will have 2 times no, not half, 2. Sorry. This is 2. Why half? So I need 2 outside. So it's the opposite. I have 2 here, and I have half outside. So call it I. Yeah. I have the space. I need the space for this. So I will be 2 integral of du over u. Of what? E to the power 0 plus e to the power 0, that will be 2. Yes. E to the power 0. Yeah. Integral is from 0 to 2. Yeah. E to the power 0, u will be e to the power 0 plus e to the power 0. That give me 2. The other one, at 2, it will be e to the power 4 plus e is minus 4. Okay, so that will be 2 ln absolute value of u from this to this. So it will be not 2/2, sorry. Yeah, that will be half. So that will be half len of this minus len 2. In other words, it's half len all of this over 2, which is, I can write it len square root over this. Okay. Yeah, this is the short one. I link it with some old exam problems. Not old exams. I link it with the questions. Oh, I mean, at the end of the book. I select some questions which are very nice at the end of the book, especially this problem solving things, which are not easy one. Yeah, I have some questions there, which they're not easy one. Okay, let us try to do those ones. Yeah, this one, we need to rewrite it as a Riemann sum. Yeah, we did something similar before. So if we look at it, this is what? This will be limit. Yeah, that will be limit. We try the summation now. N goes to infinity. Okay. That will be summation. I equal 1 to n. Okay. What is this? Before I do this, I can rewrite it as limit n goes to infinity. I need 1 over n. So this is square root of 1. I need delta x. So this one I write it n into the power half. So that gives me limit n goes to infinity. I have 1 over n outside, square root of 1. Yeah. That I can rewrite as square root 1 over n, square root 2 over n, plus a square root n over n. Yeah. So now it's very clear. That is what? So this one will be limit n goes to infinity. I let delta x is 1 over n, and xi will be 0 plus I over n, because this is 1 over n summation. I equal 1 to n square root I over n. Okay, so this will be xi. So this will be limit n goes to infinity, 1 over n summation. I equal 1 to n of square root xi. So this will be my xi. And a equals 0, and b minus a equals 1. So b equals 1. So this will be the integral from 0 to 1, square root of x dx, which is, I know how to do it. This will be 2 over 3, x to the power 3 over 2. Over 2 from 0 to 1. That will be 2 over 3. Okay. This one, I think it will be easier. The same idea. I need to take n outside. So that give me what? 1 to the power 5 plus 2 to the power 5 plus n to the power 5 n into the power 5. So that give me what? Limit n goes to infinity, 1 over n, 1 to the power 5 plus 2 to the power. Let me do it right away. That will be 1 over n to the power 5. Since I have good space, let me write it easily here. N goes to infinity. I have 1 over n. The remaining is what? 1 over n to the power 5, 2 over n to the power 5, plus n over n to the power 5. So this limit is what? 1 over n times what? Summation equal 1 to n I over n to the power 5. Now do the same thing. Delta x equal 1 over n. xi is 0 plus I over n. So that summation or that limit will be 1 over n summation I equal 1 to n xi to the power 5, which is what? The same idea. A equals 0, so b equals 1. Since b minus a is equal to 1. So that will be the integral from 0 to 1, x to the power 5 dx. Yeah, which is what? Which is x to the power 6 over 6 from 0 to 1, which is 1 over 6. Okay, two more or three more problems. Yeah. Yeah, this one for the estimation. I think it's good to know it. Yeah, this one is easy to prove. Since I know, let me do the proof here. If x is greater than m less than or equal capital M, so the integral of m from a to b will be less than the integral from a to b f of x dx, less than integral from a to b of capital M dx. This is just a constant, so it will be mb minus a, and this will be capital mb minus a, which give me this. Now, how to do it to estimate this? Square root 1 plus x to the power 4. Yeah. I have this function. I need 4.1 for this. So I have this function. I need to find absolute maximum and absolute minimum over this interval, which is we can do using 4.1. I need f prime will be what? 2 square root 1 plus x to the power 4. Here I have what? 4x cubed. It equal to 0. So I have x equals 0. So I need just to check the endpoints. F of 0 will be 1, and f of 1 will be square root of 2. So very clear, the function, this function, is between 1 and square root of 2 over this interval. So that means the integral from 0 to 1 of this will be less than or equal the integral of 1 from 0 to 1, and the integral of square root of 1 square root of 2 dx. So this integral will be for sure between 1 and the square root of 2. So this integral, I can bound it between integral of this, which is 1, integral of this is square root of 2, since it's from 0 to 1. Okay. I'll do these two range integrals. They are not linked to these hyperbolic since at the end of the book, and these are nice problems. Then I will try to do. They are not direct one. Let me see. Okay. Integral. I want to find the integral from 1 to 4, 1 over square root of x plus x dx. Yeah, I have a square root of x. Usually when I have a square root of x, I have what? Yeah. Let me try to do it this way. 1 to 4 dx. Let me take a square root of x common factor. I have 1 plus x to the power 3 over 2. Okay. Would that help? So I put this u. This is the u in the denominator. No. No, it's not x to the power. Sorry. That will be x to the power half. Yeah, I think this will work. Yes. Now it will be x to the power half plus x. Yes. So I let u equal 1 plus x to the power half. Du will be half x to the power half, x to the power minus half dx, which is 1 over 2 x to the power half dx. So I need 2 here and half outside. That will be half. I have, this is du over u, which is easy to do. Now the integral will be from where to where? It will be from, instead of 1 plus 1, that will be 2. 4, it will be 3. So that will be half ln of u from 2 to 3. That give me half or 2. No. Sorry, I need 2. But this is already 2 in the denominator, not half. I need 2. So that will be 2 ln 3 minus ln 2. Yeah, that's what we get. Okay. This one. 1 over sine square plus 4 cosine square. I need to find the integral, the area, integral from 0 to pi over 4, because it's positive, there's nothing to worry about. 1 over sine square. Now, how to do this integral? Yeah. I have sine square plus 4 cosine square. Okay. I have square. One way to think about it, since everything is square, the things which I can't remember about the formula, I need secant square or cosecant square. So why not I multiply by, or I divide by cosine square, the denominator and the numerators. Okay, like I'm multiplying by cosine square over cosine square. But I do this as a quotient. So this would be 0 to pi over 4. In other words, I'm having 1 over cosine square over here 4 over cosine square. Yeah, I think that will do it. So I have what? 0 pi over 4 secant square dx over sine square over cosine, which is tan square plus 4. Yeah. So if this is u, this is du. That will make it. You let u tan x du will be secant square x dx. So that give me what? Tan 0, 0. Tan pi over 4 is 1. I have du over u squared plus 4. And this is easy to do. This is tan inverse. So this would be half tan inverse of u over 2, where a is a square. 4 is 2 square. From 0 to 1. So that give me half tan inverse of half minus half tan inverse of 0, which is 0. So that's what do it. I think these are nice problems from the end of the book exercise. So we did 5.9, which is nothing, just returning the formula with some substitution. But you need to be careful sometimes with some questions where I change the problem into exponential problem, like this one, and then I will solve it as exponential. And yeah, some of them you need just a substitution. Okay, let me stop the recording. Yeah. Thank you.